Welcome to homeworklib.
In a triangle ABC, if the measure of angle A equals 1/2 times the measure of angle B equals 2 times the measure of angle C, what type of angle is the interior angle at vertex B? Let's begin this question by seeing if we can work out any of the angles in the triangle using this relationship between the angle measures. The best way to approach this would be to take one of the angles and define it with a letter. So, for example, we could define the measure of angle A as x. Then we know that the measure of angle A is half the measure of angle B. So the measure of angle B must be 2x. If we find this hard to work out, we can rewrite this part of the equation. Since the measure of angle A is half the measure of angle B, then by multiplying by 2, we have that 2 times the measure of angle A is equal to the measure of angle B. And since we defined the measure of angle A as x, then that's why we have that the measure of angle B is 2x. Next, let's write the measure of angle C in terms of x. This time, we can use the relationship between the measures of angles A and C, which is that the measure of angle A equals 2 times the measure of angle C. To find the measure of angle C, we would need to divide both sides of the equation by 2, so 1/2 times the measure of angle A is equal to the measure of angle C. And as we define the measure of angle A as x, then we can write that the measure of angle C is 1/2 x. And if we wished at this point, we could sketch a diagram of triangle ABC. Something like this. And now we can consider if it's possible to find a value for each of these angle measures. We can recall the property that the interior angle measures in a triangle sum to 180 degrees. We can write that the three angle measures of 1/2 x, x and 2x sum to 180 degrees. And simplifying the left-hand side, we have 3.5 x, or 7 over 2x, which equals 180 degrees. We can then multiply each side by 2 and divide by 7, either in one step or 2 steps, to find that x equals 360 degrees divided by 7. We can keep this as a fraction, but sometimes it helps us to get an understanding of the size of the value if we see it as a decimal. And 360 degrees over 7 is approximately 51.4 degrees to 1 decimal place. We were asked to work out the type of angle at vertex B, and so we first need to find the value of this angle in degrees. We defined this angle to be 2x, and although the level of accuracy doesn't really matter here, it's always best to substitute the most accurate value, which is the fractional value. So we can write that the measure of angle B is equal to 2 times 360 over 7 degrees. This can be simplified to 720 over 7 degrees, or 102.9 degrees approximated to 1 decimal place. We can recall that one of the types of angles is an obtuse angle, which is when the angle measure is greater than 90 degrees and less than 180 degrees. This is exactly what we have here for the measure of angle B. We can therefore give the answer that the type of angle at the interior vertex of B is an obtuse angle. But of course, in this type of question, it's always good to check our answers. In this case, finding the value of all the angles in the triangle is a great way to do this. We calculated that the measure of angle A, which was x, is 360 over 7 degrees, or approximately 51.4 degrees. Angle B was 2x, so 720 over 7 degrees, or approximately 102.9 degrees. Angle C will be 1/2 x, which is 180 over 7 degrees, or approximately 25.7 degrees to 1 decimal place. Adding up these values would indeed give us the angle sum of the triangle, which is 180 degrees. Although if we use the decimal approximations, we may not always get a completely round value of 180 degrees simply due to the rounding errors. As a final check of the values, we can check that they do have the original relationship between the values that we were given, that the measure of angle A equals 1/2 times the measure of angle B equals 2 times the measure of angle C. And these do, which confirms the angle measure for B, and that the type of angle is an obtuse angle.